Good day, everyone. We are Group 1 and we will present our mind map about the population dynamics. First, let us define what population is. According to the lecture for this module, population is the group of individuals or interbreeding and potentially interbreeding organisms of a single or same species living in the same general area. Now, there are population dynamics that affect the population over time, which are illustrated in our mind map. First is the demographic factors. An area's population can be affected by 4 demographic factors: birth, death, immigration, and emigration. Both birth and immigration increase the population. Birth, or natality, is the production of newborn offspring for the population, while immigration is the arrival of new individuals from other areas in the population. This leaves death and emigration as the factors reducing population. While death or mortality is the loss of life of individuals of the population, emigration happens when individuals leave the population for other areas. Next is population growth. Population growth is quite simply the growth of a population, an increase in its total number of individuals. This relies on biotic potential, which is the maximum reproductive rate of an organism influenced by sex ratio and age distribution. Naturally, with how most species are designed to produce offspring, a population can grow indefinitely through exponential growth, which is depicted in a graph as a never-ending J-curve. However, populations are not allowed to grow indefinitely. Their environment places limits upon them, such as the amount of available land and resources. The most a population can grow within these limits is called its carrying capacity, of which, if depicted in a graph, a population's growth will curve into a plateau, resulting in the S-curve graph of a logistic population growth. Furthermore, to know the limits to a population's growth is to know the limits imposed upon it by many kinds of factors, whether they be dependent on a population's density like diseases and predation, or independent like weather and climate. To understand these factors means we can understand how to affect the growth of populations, most notably our own, but also whether it can be to sustain growth of beneficial species like livestock or to mitigate the spread of harmful species like parasites. Next is measures of population. To measure population, one should determine the population size, which is the number of individuals in a population, and the population density, which is the concentration of individuals in a particular area. As you can see, the population size is connected to population growth because it is intimately related to each other, in a way that we are basically talking about population size when determining population growth. Now, there are 2 sampling methods to determine population size and density, namely the quadrant method, which is used for immobile or small, slow-moving organisms, and mark recapture method, which is used for moving organisms. Furthermore, there are 3 types of population distribution. They are uniform dispersion, where individuals are evenly distributed; random dispersion, where individuals are distributed with no predictable pattern; and clump dispersion, where individuals are distributed in clustered groups.
Next is population regulation. As we've just learned, all population growth is regulated. These regulations come in 2 types: density-dependent and density-independent, the former relying on a population's density while the latter does not. Density-dependent factors are usually biotic in nature, since biotic factors tend to spread more easily when a population is more densely packed in an area. These biotic factors include disease, predation, and running out of essential resources. Meanwhile, density-independent factors limit population growth regardless of a population's density, such as weather and climate, since they don't discriminate in affecting areas. In fact, while a population influences density-dependent factors through its numbers and density, density-independent factors influence populations. A hot climate would bring about deserts which less individuals will settle, for instance. We now move to the properties of population. There are 3 properties. The first property is the life tables. As its definition states, life tables provide a clear and systematic picture of mortality and survival in a population. Life tables can be used to, first, analyze probabilities of survivorship of individuals in a population. Second, determine ages that are most vulnerable to mortality. And third, predict population growth. There are also types of life tables used by ecologists. The first type is a cohort age-specific horizontal approach. It is constructed by following a cohort of individuals, a group born within a single short span of tune, from birth to the death of the last member. Examples include group of plant seedlings that germinated at the same time, and group of birds born during the same breeding season. The second type is the static, current, type-specific vertical approach. It estimates pattern of survival in wild populations and record age at death of large number of individuals. These are the assumptions when using this life table. First, individuals in the sample are born at different times. Second, individuals die at birth and recovered after death. And lastly, estimate the age of dead individuals. The second property of population is survivorship curve. The survivorship curve graphs the survivability of a population's individuals from their youth to senior years. There are three types of survivorship curves. The first is type 1, the convex curve where population individuals live for their entire lifespans. This means that in type 1, mortality rates are low until they reach the end of their lifespans, which is their senior years. Additionally, humans belong to type 1. Next is type 2, where death rates are equally distributed regardless of age, resulting in a straight line rather than a curve. Finally, type 3 is a concave curve, where it is the youth who experience the highest mortality rates. And lastly, the third property of population is the age-sex pyramid, in which members of a population are clustered according to age and sex. Next is types of population. An area's population consists of all individuals belonging to a single species living in this specific location. There are two kinds of population, heterophorous and semmelphorous. Heterophorous populations have a single reproductive cycle, meaning an individual can only reproduce once in their entire lifetime. This means that individuals give birth to many offspring and lack age groups since all individuals are born and die at roughly the same time. Semmelphorous populations, meanwhile, have many reproductive cycles, meaning individuals can reproduce offspring many repeated times. This also divides the population into age groups since not everyone is born at the same time. They grow at different periods, of which individuals in similar stages in their life are grouped together to form these age groups. Lastly is the population boundaries. The boundary is a physical area that defines a population. There can be more than one population within a particular boundary, but also the boundary of a particular population can be in a different area. There are two types of boundaries within an ecosystem, the natural and the arbitrary boundaries. Again, we are Group 1 and thank you for listening.